What if we could grow food in Mars using the waste? Sounds magical, right? Hi there, myself Mohammad Mashur Rahman, introducing Project Metamorph, and I have a story to tell. One day, 8 of our NASA astronauts started their journey towards Mars. They trained for years, they traveled millions of kilometers, they studied rocket science and black holes to get there. But upon landing, they faced surprisingly simple but a creative problem, that is trash. Picture this: 8 astronauts, 3 years, they will produce nearly 12,600 kgs of inorganic waste, nearly size of a 4 fully grown elephant, just sitting there useless and dangerous. So, what do we do? Bring it to Earth? No, that is too heavy and costly. Now, can we grow food plants using them? But why don't we bring food from Earth? Well, then we actually need to squeeze 50 tons of foods, nearly size of 10 elephants. And who wants to eat same kind of food every day? So, it is way better to grow food plants of our own. So, we don't bring it, we need to create it. To help our astronauts, I prepared a magic mix to grow plants on it. This consists of char, textiles, and Martian regolith. What is char? Kind of similar to charcoal. So NASA already have some cooking system called Oscar AOWG. They basically burn plastics and textiles and other wastes into high temperature and pressure to produce syngas, fuels, and other gases. The solid residue of this process is char, which have high amount of carbon and nutrition. So I produced char by simple burning some plastics and textile waste. The next is the problem itself, Martian soil or regolith as they call it. It has lifeless rock dust and toxic chemicals called perchlorides. It is very important to utilize in situ resources for long time colonization on Mars. So I have tried to replicate the same Martian regolith with the help of NASA MGS-1 data. Here is the table of the materials I have used. According to the below NASA paper, 70-30% is the optimal mix of char and regolith. The final piece of the puzzle is cotton pulp. We can derive it from textiles, tissues, and papers. It is a natural source of cellulose, which is absolutely perfect for getting seeds to penetrate, keeping them hydrated for germination. So together, char and cotton pulp makes the perfect mix for plants even on Mars. Cotton pulp is excellent for short-term benefication like hydration, root establishment. Char provides long-term soil health like nutrient retention, microbial habitats, and fertility. It is a brilliant idea, but does it work? The answer is huge yes. I have been successful to grow food plants on this char, cotton pulp, and regolith mix in just 3 days. So for the final overview, I took char as a solid byproduct from test to gas technologies, mixed with regolith with 70-30%, added cotton pulp derived from waste textiles, put the seeds, and bam, microgreens appear. I built this interactive website to show how we can grow food on Mars by finding the perfect mix of char, cotton pulp, and regolith and learning the water, temperature, and light needed. It's a game, but it's also a glimpse of the future. But this idea of turning trash to treasure is way beyond just growing food. It's about using some structural waste to solve critical challenges and improve quality of life on Mars. Gravity on Mars, it is only 38% of what we got here on Earth, which is fun until your bones actually starts to weaken. So this exoskeleton made from mostly carbon fibers, which is super strong and lightweight, and it helps to share the load, prevents injury, and reduce fatigue. Final overview: instead of being buried under 12,600 kilos of useless junk, we are building a cycle of life, strength, and energy out of waste. This means astronauts stay healthier, habitats become more sustainable, and Mars mission become lighter, cheaper, and way more possible. It is a closed loop system where everything has a second life. If trash is key on Mars, what we are wasting on Earth, what incredible potential we are just throwing away.